Okay, so we're on part 3. I think we're still talking about the normal distribution. We're kind of going to do things backwards today. So instead of starting with the percentile, instead of starting with the value, we're going to start with the percentile. So when you're given a percentile, you want to find so go menu 653. So let's see what that is. So it's a command that's very close to norm CDF, but it's not norm CDF. So menu 652 is norm CDF. 653 is inverse normal. It's the backwards version of this command. So here you have to start with an area. So let's see what we need to do this. What would be the value of the 90th percentile for the normal distribution of ITBS scores in Gary, Indiana on the night? So let's go back to the command. So we want 90th percentile. So 0.9 is what I would put for area. If it's z-score, you just kind of like, you just say it. So z-score would be 1.28. So 1.28 standard deviations above the mean is equivalent to the 90th percentile. So there you have actual values here. So let's use the values from. So once you solve for z, 1.28, you can then plug that in for the standardized score for z. And then if you know, going back to the example we did previously, you know that the mean is 6.84. So you subtract that, and then the standard deviation is 1.55. You solve that, so use algebra to solve that, or the solve command, and you get 8.824. And so we figured it was 1.23, so we knew between 8.39 and 9.94 because it's 1.28 standard deviations above the mean. But this will give you the exact value, so doing that, those steps. So the first method is to use a calculator to find the z-score. So that's what I did here, right? So I went, make sure when you use a calculator command, so when you go to menu 653, you can see what I put in. I put in the area, 0.9. I put in the mean was 0 and standard deviation was 1. That's true for any z-score. So I just first find the z-score doing that method. Then I use that z-score of 1.28 and I plugged into the formula, used some algebra or the solve command, and found that the 90th percentile is located at x equals 8.824. Again, make sure, I like the way they said that there. So they said area is 0.9, the mean mu is 0, and standard deviation is 1. You don't have to put that extra thing about the left here for the TI Nspire. Okay, so there's another method. So same problem. Can you just use a calculator to find the answer? So this time, we're just going to plug in the stuff we know. So we're going to go menu 653, 0.9, that's still the same. But if you put the actual mean, which I think was 6.84, I remember, and 1.55, I think was the standard deviation, it'll just jump right to the answer. So it saves you the step of solving the z-score equation. It's a little bit faster. That's probably what I would do. Again, you don't need the left there. That'll be the easiest and the quickest method. I do recommend drawing the normal distribution. It helps you grasp the problem, figure out where the area is. Sometimes it helps. It really helps. It's a great habit to be in. You can use technology, again, to find the value, standardized value, and then use that to solve it if you want to use algebra, or you just go straight to the answer with the inverse norm. We talked about that, so don't just say the calculator command as your work, but you have to, I like the way I said the last time there. So area is 0.9, mean is 6.84, standard deviation is 1.55. Okay, the heights of 3-year-old girls are approximately normally distributed with a mean of 94.5 and a standard deviation of 4. 75% of 3-year-old girls are taller than what height? So let's get our calculator out. I'm gonna bring it over here so you can see it better. Okay, so we go to our command. We're starting with a percent or percentile essentially there. So menu 653.75. The easiest way to do this is just to put in the mean and the standard deviation. Mean of 94.5. Standard deviation of 4. That gives you the answer. You could have said 0, 1. That gives you the z-score. Then you could use the z-score equation. So you could solve, that equals x minus, I think it's 94.5 over 4, comma x. And it gives you the same answer, 97.198. Great idea to draw it. So I really like sketching it out. Getting, just get in the habit of doing those tick marks. In this case, 4 centimeters. Using technology and then doing the algebra if you want to put in 0, 1. Okay, sorry. According to, so I'll just do the same problem a different way. According to a study, people spend an average of 1.25 minutes on their smartphone each time they pick it up. If the distribution of smartphone use is approximately normal with a mean of 1.25 and the 97th percentile of 2 minutes, calculate its standard deviation. Ooh, it's interesting. So, what did they give us? They gave us, so mean of 1.25. We don't know the standard deviation in the formula, the z-score formula. 2 minutes is the value in the formula, and 0.97 is the area of the curve. So we still need to do, I think we need to do, inverse norm with the 0.97 to get the z-score. I think that would be right, 653. So 0.97, if I do that, I get a z-score of 1.88. So now I know the value, I know the z-score, I know the mean, I don't know the standard deviation. So think at that point, you would plug in to the formula. So here it is. So you plug in the 1.881, that's the z-score. 1.881 standard deviation is above the mean. 2 is the value, minus the mean of 1.25 over the standard deviation. Use your solve command to solve that would be fine. Right, so what I mean is, solve 1. I'm just going to grab it. I like to grab it so I don't have to round it. If you mouse up and press enter, you can grab that. Equals 2 minus 1.25 over x for standard deviation. Solve for x. Comma. I think I forgot to put the comma. I have a janky computer sometimes. Oops. Comma x. There we go. Okay, so 0.3978. So if you solve that for standard deviation, you get 0.3978. Yeah. Okay, so that's the lesson for today. It's very quick. You had a quiz here, probably in class. It took up a little bit of time. Dairy farms are big business. We already read this a little while. So the question was, this time, how much milk is produced by the least productive 10% of milk cows? So, we're starting with a percentage here. So let's see if we can do this. So menu 653. percentage is 0.1, mean is 12.39, standard deviation is 4.32, and you get 6.85. So how much milk? 6.85, right? So again, you could have done it. They did it. Found the z-score, negative 1.282 standard deviations below the mean. They plugged that in the formula, used the solve command or algebra to solve, and get 6.85 kilograms of milk. That's how much the least 10% would. These folks investigated barefoot running at Central York High School by recording the 50-yard sprint times of students who didn't wear shoes. Ooh, it's rough. Times followed a normal distribution with a standard deviation of 1.03. At the first quartile of the distribution of sprint times at 6.78 seconds, calculate the mean. Okay, see what we've been given. So we have it's normal distribution. It's great. Standard deviation is 1.03, so we know what to divide by. If the first quartile of the distribution, so sprint time is that. Ooh, okay, so first quartile is what percent? That is 25%. So let's find the z-score for that. So menu 653.25. Let's just do z-score of that guy. So we know the z-score is negative 0.67. So we can plug that into the formula. We know that the value in the formula is 6.78 minus the mean as m over standard deviation 1.03. So you just set it up and solve that equation right there. Just use algebra or the solve command and you get 7.474 seconds. That's your lesson for today.